Good afternoon, EGC. This is an old member. I go by new name Ghost now. You can find me via the Steam Ghost. I have currently been added, as well as a couple other admins I knew from many years ago. My new name will be Ghost for specific reasons. I had deleted my previous account, which was under the name Little Mad Tiger. You can also find me via whatever social media platform you want. You just have to PM me via the forums or via Discord or Steam. So let's dive right into it. So I know I have done videos in the past in regards to programming, in regards to Python resources, intro to programming, a lot of more back-end software related intel. But another part of computer science that I think is very important for people to understand is networking. And this is the intro to networking. I'm going to post the video inside this topic here. So once I post it, it'll be up and available for all of you. So I'm going to go into a specific detail on how users request information on the internet, and that information is derived back to them. Now, i.e., for an example, let's say I type in google.com. I hit enter. That data is then transferred into the network and is processed and then sent back to the user as google.com. But how does that actual process work out, and how does that end up coming back to us the right way? So I'm going to dive into the OSI model, which basically explains this process. We're going to first start off with the physical layer. First and foremost, your computer and laptop is the physical structure. You also have your cabling. So you have your coax cables, your fiber optic cables, you have a wireless adapter, you have hubs which connect multitudes of users, and then you have repeaters, which is essentially it speaks for itself. And then you have your data link. This is the next step in the process. This is actually turning what the host is requesting into a data, or basically data link. Essentially, it will turn it into what is called frames. That is basically turning the data into specific sets and number frame. Basically 32-bit, 64-bit, etc. Then you have Ethernet, basically from host to network. You have PPP, point to point. This is essentially connecting a host to two different routers. Then you have a switch and a bridge. I would actually say that a switch is more useful in my opinion because this connects all users, whereas a switch connects all users and derives them into a network differently through different ports. So now we get into networking. This is where our frames turn into packets. It's actually made into IP schemes, etc. So we actually have internet protocol in regards to getting this information sent back to the user. We have three different sets, which is ICMP, IPsec, and then IGMP. ICMP, Internet Control Management Protocol, is essentially, let's say there's an error happening with the packet. This will allow the program to realize that, hey, this is an error in the packet, and allow it to find the correct information. IPsec. This is a lot found in VPN services, so virtual private networks. Essentially what this is allowing to do is it's feeding the specific packets in a very specific way, allowing for users to go through the difference between going through the network to the application server in a very secure manner. It's a security implement. Both of these are. And then Internet Group Management Protocol, basically grouping different packets all together. So now let's hop into the transport aspect. Now, I'm not going to touch on UDP, mainly because it's unreliable. TCP is the main model we use, so Transmission Control Protocol. Essentially, this is the gateway between your application servers and your IP packets. Basically, hey, I have this specific IP packet. I need to go to this specific server and pull services from that server. That is what end-to-end connections is basically your communication between your application servers and as well as your overall network. And then for these next three, I'm not going to go into every one of them. I'm just going to go over a brief explanation of what all three of these are combined together and what they essentially mean. So basically what this is allowing you to say is, hey, this user is finally getting this information back in a very specific manner through either secure shell, domain name services, secure shell license, an image management acquisition, file transfer protocol, a JPEG, hypertext transfer protocol, a chat line, whatever it is. It's sending that information back to the user. A DNS is just what that is doing is just allowing it to fault back to a specific IP, allowing the user to pull from services. And then basically, let's say that you requested Google. You're going to see that sent back to you as an HTTPS, which is a hypertext transfer protocol secure website, essentially saying that that packet is being sent specifically back to that user to that specific IP in a secure fashion. Now, I know I went over these very, very quickly. If you have any questions or concerns, please message me on Steam, Discord, or the forums, and I'll be happy to assist you in understanding specifically what all these steps mean and what each segment actually is pertaining to. Another program that I believe, in my opinion, would work out is Packet Tracer. What that does is it allows you to mimic Cisco routers and switches, allows you to identify that specific process and see it in real life where connection point between application servers, users actually occurs, and to see how much connection line there is, and to see what is bad, what is good, etc. All right, thank you, everyone. I hope you have an amazing rest of your Thursday, and leading right into the weekend, I'm going to post more videos here momentarily. So thank you very much for watching. I'm out.